make this as concise as possible. There's our op-amp power supply and our 5 and 10 volt power supply. Here is our circuit that works pretty well. We don't get a full 5 volts, but it works the way it should. As you can see, here is our non-inverting op-amp. Goes down to our Wheatstone, and then there's our instrumentation with 3 op-amps. This is our R5, the value that will be changed. To add 10%, we were able to simply put 2 resistors in series. But for the 10% less, it was a little difficult. So what I did, I had some spare parts laying around. I have a trim pot here with a 1000 in series, so that gives us about 1800 ohms. So we just hop these guys, put them over there. Alright, so here's a little demonstration. First part, we're showing the balanced Wheatstone. Everything is 2000, everything should be good to go. And we're going to turn on our 10 volt. Right. And we get not exactly 0, but as you know in real life, these things always come out 0, but I feel like that's low enough to prove that we do have a fairly decent 0 output. All right. And now we're going to show next the 10% increase in the Wheatstone bridge. Okay. And so for our Wheatstone here, it's a little hard to see, but we have 2 resistors in series together. That will give us a almost 10% difference from the value of R4. So let's go make sure that's not touching. Okay. And we're just going to turn on our 10 volt supply. 10 volts. And on our output of the entire circuit, we have around 3.15 volts, which isn't 5, but for the resistors that I've chosen, it's about where I'm looking for. Running through the test, we do know that our Zener diode works, and we get consistent results. So let's hop down to another unbalanced Wheatstone of 10% less. And as I might have explained earlier, getting a good resistor value for this didn't work that well. So what I did was I jumped from there to down here. And this is my trim pot here that I've been able to trim down to about 800 ohms. And this is a 1000 ohm in resistor to give us about 1800 ohms for that value. And what we should see is a negative voltage, seeing as VB, the Wheatstone is larger than VA, and VA is going to be subtracted from VB. So let's come over here, turn on our 10 volts, and we get about the same result, negative 3.7 volts on the output. So that works out pretty well. And for the next part, we're going to increase our voltage by 5 volts on the source. And back down to our original circuit. Running a bit of voltage to this thing. Our diode is getting a little warm, so we're going to do it real quick. We've stepped up to 15 volts from 10. Looking back, it may have been a good idea to start around 7 or 8. Our breakdown voltage of our diodes around 7.5 volts, but it'll work for now. So we're back to balanced, and as you can see, we're running close to 0. Not bad. Not ideal, but I think it's about as close as we're going to get. So there's 0 on the balanced Wheatstone bridge, and we'll put our 10% higher resistor value in our Wheatstone. So our 10% increase there. It's a little rickety, but it works. You can see we have 15 volts running in and about the same coming out thanks to our Zener diode. All right, now we're going to step down to 10% less on the Wheatstone. Okay, and our last part. Once again, we've jumped our trim pot into our circuit there. And running 15 volts, channel 1. You can see we have about 35 milliamps. And just as expected, we've got a similar negative voltage on the output. So our circuit works. Doesn't quite get up to 5, just due to the resistors not being what we want them to be. Have in my hand, but she works.